It's a great topic. Obviously, it's one I've spent a lot of my career thinking about, and my childhood before AI became a career. I want to start by mentioning a workshop I organized with Idemar Arel and Rod Furlan in 2011. It probably was, which was at actually no, it was much earlier than that. It might have been 2006 or seven at University of Tennessee in Knoxville, and that was originally on the path to AGI, and we gathered like a dozen AGI researchers together in 2008 or whenever it was to discuss the path to AGI. And the paper we ended up publishing out of all that, put together somewhat heroically, mostly by Sam Adams from IBM, who's been a great AGI researcher for a long time. The paper ended up being called Mapping the Landscape of AGI. And the reason was that we couldn't get two researchers in the group to agree on what was the path to AGI, right? So we ended up choosing a somewhat hackneyed but more accurate metaphor. Like, if AGI is the peak of a mountain, or a set of peaks of a mountain, there may be many paths up to that peak, right? And what you found is that almost everyone in that workshop agreed, like, on what things you needed your AI system to master to be a human level AGI. I mean, setting aside the idea that humans are not maximally general intelligences anyway, but if we're just talking about human level, human like AGI as an interesting sub goal of creating superhuman superminds, I mean that everyone pretty much agreed, like, if you could make a robot college student go to MIT and pass all the classes, like walking around, talking to the other students and the teacher, doing all the stuff a human student did, then probably we want to call that robot college student, after he gets his PhD in multiple fields without cheating, we're gonna call that guy a human level general intelligence, right? So we can mostly agree on that, but the folks whose thing was robotics thought the first thing on the path was to master perception and action, then language you deal with after that. The folks whose thing was NLP thought, like, first you master language, and then you can deal with the details of input output, like perception and action after that. The guys who deal with reasoning thought, of course, first you master, like, uncertain abstraction and reasoning and inference, and once you got that, that's the core. You can add special applications like language, perception, and action after that. So we found, and this was like a dozen people who'd been spending their careers doing very good research toward AGI, but we found everyone sort of agreed where we wanted to go, but didn't agree on what the path was to get there at all. And then this has very real applications for, like, what metrics do you want to measure to assess someone's progress toward AGI, right? Because the metrics that you define sort of correlate with what path you want to proceed along. And of course, if you say Steve Wozniak proposed what became known as the coffee test, like, make a robot that can go into a random house in the US and figure out how to make a cup of coffee. And if you're robotics oriented, that's a great test, right? If you're abstract reasoning or NLP oriented, you could say that's a ridiculous test. And if you're reasoning oriented, you might say, like, a Stone Age tribes person can't solve that, but has as much general intelligence as we do. So I mean, there's a lot of ways to look at it, right? Because some people think making an AI to solve chemistry exams or prove theorems is a great path to AGI, and others think that's, like, often some little corner. So I I will tell you something about what I think is the most plausible path to AGI, but I do tend to believe the landscape metaphor. Like, I don't doubt there are many different paths to AGI. Just like if you take, like, space flight or something as an example, there's going to be many different ways to do it. Now, of course, once you know all the laws of aerodynamics and the physics of propulsion, you can sort of understand the relation between all the different ways to do space flight, right? And all the different ways to do flight in the atmosphere. Since we don't have a theory of AGI that's as useful as the Navier-Stokes equations or our theory of propulsion systems, like, we don't yet have the theoretical background to really place all these different ideas of the path to AGI into a common understanding that well. So I mean, if we look if we look at the high level, you could say approaches to AGI being taken by serious people in the world today. I mean, there's people really trying to model the brain and use that to create AGI. Not too many, but it exists. I mean, there's people making a general mathematical theory of AGI, say Marcus Hutter as a lead example. You could look at his book, Universal AI, and then trying to create practical AIs as sort of simplifications of an abstract, super powerful mathematical AGI system. There's an artificial life approach, not too fashionable now, but people have tried to make artificial ecosystems in which AI would emerge. There's cognitive modeling type approaches. You get a cognitive architecture emulating how human thinking works, and you don't care that much how the brain realizes it. You care about what are the psychological processes. Then there's a more computer sciencey approach where you're just looking at piecing together algorithms that solve problems. And there are many mixes, right? Like modern deep neural nets is really a mix of neuroscience inspiration with computer science algorithms. And my own approach, which is more neurosymbolic, as exemplified in the OpenCog system and the new OpenCog Hyperon system. I mean, it's heavily math oriented. It's also cognitive science and computer science oriented, not so much neuroscience oriented. So, I mean, you have a lot of pure approaches, and then in reality, you take an impure approach, right? And then another big dichotomy you could look at is sort of emergent approaches versus engineering approaches. Like, to what extent are you building the thinking processes in the AGI and building the perceptions and building the ideas and building the cognitive biases versus to what extent are you building a system, a sort of self-organizing system in which the intelligence will emerge, right? And again, in theory, you could take an extreme approach. In practice, it often tends to be a mix. Like you're building something, and then it's learning, and some sort of complex network is emerging within a framework that you've built. And there are differences of opinion about what you should build in, which embodies some theory of how human-like intelligence works, versus what you should allow to emerge, right? And then another question that people don't agree with is, what's the relation between all the narrow AI, the task-specific AI that's out there now, and AGI, right? So, I mean, at one extreme, you have people who believe narrow AI will just gradually broaden its scope and get better and better and becomes an AGI. So you could say like, well, okay, GPT-3 doesn't really understand what it's talking about now, but it understands what it's talking about, better, a little better than the original BERT model did, which understands what it's talking about in some ways a little better than statistical NLP from 10 years ago. So we just keep going and gradually we'll get to understanding. So that's one point of view. Another point of view, which say my friend Pei Wang with his non-axiomatic reasoning system approach to AGI would hold, or Douglas Hofstadter would hold. I mean, another point of view is that these narrow AI systems have no more to do with human-like general thinking than linear regression does, right? I mean, they're basically curve-fitting models trained on huge data sets. They're not carrying out imagination, self-reflection, creativity. They don't understand context. So they're just doing a fundamentally different thing than what AGI is. And my view is a little bit in the middle there. Like, I think we're learning something about AGI from all these narrow AI systems. And I think in many cases, the narrow AI systems we have now, they may embody principles that end up inspiring components of an AGI system. But I don't think the narrow AI systems we have now can just be like continuously grown into an AGI system, nor that you can like glom together a bunch of current narrow AI systems as modules to get an AGI. But again, there's a great spectrum of views on all this.